Sorry, my video got cut off again. So back to the horizontal stretch and compression. If we have y equals a to the x and y equals a to the cx, this is going to take our x value, x and y value to x over c comma y, and it's a horizontal stretch if c value is in between 0 and 1, and it's a horizontal compression if c is greater than 1. So we're going to do y equals 2 to the 1/3 x, or 2 to the x over 3. Alright, so this is going to take -1, 1/2, 0, 1, and 1, 2, and it's going to map them to, so c from here, from our formulas, if this 2 is a, then c is going to be 1/3. So I need to do x over 1/3 comma y, or when you divide by a fraction, you multiply by its reciprocal, so 3x times y. Okay, so this is -3 comma 1/2, 0 comma 1, and 3 comma 2. So it stretches the graph horizontally. So 1, 2, 3, 1, 2, 3. Okay, so at -3, that's where -1 would have been. And 2 is at 2, and then it grows, oops, exponentially here. Still with a horizontal asymptote at y equals 0. Okay, so those are all the transformations you can do with exponential functions. So if you just have a graph of y equals a to the x, and you can do any sort of combination, right? You don't, like, all of those examples just illustrated one transformation at a time, like shifting up to or over to, shifting up to, left or right to, flipping it over the x and y axis, and vertically stretching or compressing, and horizontally stretching and compressing. But you can do any two combinations of them. So for example, y equals 2 to the x minus 2 plus 2 would shift the graph of y equals 2 to the x to the right 2, because we have this x minus 2 here, and then also up y 2 points. Okay, so that's how you can do both a horizontal shift and a vertical shift at the same time. Okay, so moving on. So that's how. So we're past graphing exponential functions and like transformations of them. So now we're going to find exponential function. We're going to do this example. So find the exponential function in the form f of x equals c times a to the x, that passes through these 2 points. Passes through -1, 18, and 4, 2 over 27. Okay, so the way you do this is you take your x, so you plug in 18 and 2 over 27, so you take each of these ordered pairs and plug in the x and the f of x values and solve for c and a. Okay, so if I take the first one, I'm going to put 18 in for f of x. 18 equals c times a to the -1, and -1 in for x. So really, remember, by definition, this is 18 equals c over a. A to the negative 1 is 1 over a. So 18, if I multiply on a both sides, I get 18a is equal to c. Okay, so now using this one, 2 over 27 is equal to c times a to the 4th. Okay, so we have an expression for c, so I'm going to substitute that in. So it's 2 over 27 is equal to 18a times a to the 4th. All right, so now I'm going to divide both sides by 18, so you get 1 over 18 times 2 over 27 is equal to a to the 5th power. Okay, so this, if you put it in your calculator, is 1 over 243 equals a to the 5th, which this is 1 over 3 to the 5th power. 243 is 3 to the 5th power. So a is equal to 1/3. Okay, so now I'm going to take this formula here and figure out what c is. So if I plug in a equals 1/3, it's 18 times 1/3 is equal to c, or 1/3 of 18 is 6. So your function is f of x equals 6 times 1/3 to the x power. Alright, so that's how you do an example like that. Okay, the next thing I'm going to talk about is a application of exponential functions. So there's 3 types. It's interest on loans, okay, or bank interest. Okay, so there's simple interest, and the formula for simple interest is I equals P times RT, and I is interest, P is principal, and R is annual interest rate. And T is years. Okay, so there's another, so I won't rewrite the ones that overlap here, but then there's compound interest. So I'll explain the difference here in a second too. So then this one is A equals 1 plus R over N. It's R over N to the N times T. So, oh, and we have a P here. P times 1 plus R over N to the, so the only one that we need to, two that we need to introduce here, amount after T years is A, and N is equal to so N is the number of times interest is compounded per year. Okay, and finally we have continuous compound interest. Okay, so these A, P, R, and T are the same as above here, but this E is not actually a parameter or variable. It is Euler's number, so it's like pi, right? Pi is just 3.14, goes on and on and on, whereas Euler's number is a similar number that goes on forever, but it's actually, I'll give you the first couple digits of it here. It's 2.718 2, 8, and it goes on forever. Okay, so it's just a number. E is just a number here. So there's 3 different types of interest you can have. Simple interest is where you just, very simply, you take your money, your principal, and you figure out, you plug in amount of time, you put it into an account that gathers interest, and you input that rate, and then you figure out how much interest you get after that time. So the idea of compound interest is you're taking, you add your interest, like however many times you want to compound it per year. So let's say I'm compounding my interest twice a year. So after the first half year of being in the bank or in that account, I then gather up the money, I gather up the interest I've made on my money over that half a year, and then add it to my amount, or add it to my account. And then the next half year I will take the interest on the principal and the interest I gained over that first half year. So you're gaining interest on your interest. And this continuous compound is where you just, instead of compounding it like twice a year, you just compound it continuously. So you could have compounded it daily up here, every minute, but this is continuously, like every single increment of time. Okay, so there's a couple examples. So we'll talk about if $100 is invested with a 5% annual interest, find A after 1 year of 1, interest compounded daily. Whoops, not daily. I want to say annually. Annually to quarterly. Three, monthly, and 4, continuously. Okay, so we're going to use these 2 formulas here, compound interest and continuous compound interest. Okay, so for the first one, we use our formula, compound interest formula, and we get A is equal to 1 plus R. So R was 5%, so we need to express that in decimal form. So it's 0.5 divided by n, but for the first one, n is annually, so we're compounding it once per year, so n is equal to 1. To the n times t. So t is also equal to 1. So we have up here 1 times 1. Right, okay, so that's going to tell us how much we get. So A is equal to 1 plus 0.05. Shoot. I forgot the principal part again. Right? This should be A equals 100 for P. 100 times so if you compound it once a year at a 5% interest rate, your $100 annual interest rate, your $100 return to $105. Okay? You could have told me that without the formula. Okay, so, but how about 2? What if it's compounded quarterly? So A would equal 100 for the principal times 1 plus 0.05, the R, the rate, divided by, so quarterly is n equals 4. Divided by 4 to the 4 times 1 power. So this is 100 times 1 plus 0.05 over 4 to the 4th power, which is equal to, using a calculator here, this is equal to $105. And 9 cents. So just by compounding it 4 times a year, you make 9 more cents than you would if you just compounded it annually. And well, it doesn't make quite a difference when you just invest $100. But let's say you're investing $1 million, then this 9 cents turns into like it's on the order of I think $9,000 rather than 9 cents, or no, 900 or 9,000. So the more money you invest, the more this pays off. Okay, so 3 would be monthly. So that's n equals 12. So it's a equals 100 times 1 plus 0.05 over 12 to the 12 times 1 power. So this is going to be 100 times 1 plus 0.05 over 12 to the 12 power, which is equal to about $105.12 using a calculator. Okay, so now finally, what if we just compound it continuously? Okay, so A is equal to, so this is where we use our PERT formula. So P times E to the R, which is 0.05 times 1. So this is equal to 100 E to the 0.05, which is about equal to I've got it written down here. It's roughly equal to, you can do this on your calculator, 105.1271 going on forever. Okay, so you can see the more and more times you compound, the more money you get. All right.